actually know what this is. Okay, number 8. So this one says to use the function values in the following table in the trapezoidal rule with n is equal to 6 to approximate the integral from 2 to 8 of f of x dx. And I've got x and, they use f of x, but same thing. They give us, the x values are 2, 3, 4, 5, 6, 7, and 8. The y values are 16, 19, 17, 14, 13, 16, and 20. So the first and last numbers in the x in the table are the interval that we are on, right? And you see that from the integral that's here. So a is 2, b is 8. They told us n was 6. So I can find h now by doing 8 minus 2 over 6, which is 1. So now I can use this to set up the trapezoidal rule. So t equals, it's h over 2, h is just 1, so 1/2 times, remember the first number, even though they've given it to us a different way, the first number is still just 16, and then plus 2 times each of these middle numbers, so 2 times 19 plus 2 times 17 plus 2 times 14 plus 2 times 13 plus 2 times 16 plus, and then the last number, 20. So we've got 1/2, 16 plus 38 plus 34 plus 28 plus 26 plus 32 plus 20. Well, what I have on my paper isn't what anyone has said, but that doesn't mean that it's not right.
I meant 194.
Oh, I missed it.
Okay, that's, yeah, okay.
I said 1, then I went to the final answer.
Well, that's what I thought when I was like, well, you just said part of it. Okay, so yes, that would be 97.
Wait, so did they give you the numbers to plug in?
They gave us everything that I have written in black.
Oh, okay, I was trying to figure out how you...
Yeah, they had like a little like one sentence thing, and then they have the table that goes with it, so. All right.
Yeah.
Did you just move again?
Yeah, good.
Yeah. But that didn't do it well.
All right, we're going to do one word problem and then 2 Simpsons rule problems, because Simpson rule works the same way, just the pattern of what's getting put inside is different.
Oh, okay.
But normally I skip the word problem and do it at the end, but we're going to go ahead and do it now. So it's, they give us a table. So the table below records the velocity of a bobsled at 1 second intervals for the first 8 seconds of its run. Man, we could have done this legitimately. Could have practiced this last week.
What was the last class that did bobsled? Did your class do bobsled?
It only stopped in the last, 2 years.
Like, the classes would actually go bobsledding?
Yeah. They just stopped it. Last year was the first year that they wouldn't let us run it.
They would have professional stuff like that.
So, but the 2 classes that went in the spring didn't get to do it.
Right.
But, so probably the class of 20, I'm guessing, is the last one that did it. All right. Use the trapezoidal rule to approximate the distance the bobsled travels during that 8-second interval. So they do the table like standing like up and down, but to not take up so much space, I'm gonna turn it sideways. But just anyways, you wouldn't know that if I didn't tell you, but I'll tell you anyways. All right. So t seconds, and then speed is gonna be the other one in miles per hour. So 0, 1, 2, 3, 4, 5, 6, 7, 8. And then 0, 3, 7, 12, 17, 25, 33, 41, and 48. And those are kind of smushed together, but just do this so you can see it. There. Not my best table, but it's fine.
I'm surprised the iPad didn't like straighten out the line.
Well, I didn't do it so that it would. You have to like pause and it'll do it. I just did it quickly so it wouldn't because I knew my things weren't straight. All right, so what do you immediately notice about this table without me telling you anything else?
It's proportionate to its the speed increases as time increases.
Okay, that is one thing.
Wait, okay.
What might be a problem with what we have right now?
Never mind.
Well, at 0 seconds at 0 miles per hour, that's okay.
I'll probably.
What is something in physics we always have to pay attention to?
Units. Significant.
Oh my goodness, it's seconds and hours.
Seconds and hours.
So yeah, units, right?
Okay, so yeah, so units, so we just need to be aware of that, okay, as we get ready to start this problem. So I'm just going to make a note here about units so that I know to make sure I look at that. So the width here between each one is there's 1 second difference, right? So the width, h is equal to 1 second. Well, I probably shouldn't say h. I'm just going to say 1 second. Now, speed is in miles per hour. So that means that h is in hours. So how many seconds are in an hour?
3,600.
3,600 seconds in 1 hour. Funny story about that. One day my nephew was doing something and he's in first grade, and I said something about how many seconds were in a minute, you know, how many minutes were in an hour or whatever. And then I said, so do you know how many seconds are in an hour? And he was like, well, you would multiply them, right? Which, like, I was impressed he knew that in, like, first grade. I was like, yeah. I said, you know more than some of my high school kids, because a lot of my, like, not y'all, but, like, a lot of them don't know how many seconds are in an hour. And he, like, actually figured out how many were in the hour. The only thing he had issue with was multiplying the zeros. And I was like, wow, you're really smart. He's like, how do they not know this? This is easy. And I was like, well, I was like, maybe you should come tell
Did
them.
he do the calculations in his head?
I don't really know exactly. Well, what he did is, instead of doing, that's why I said he struggled with it, because of the zeros on the end, because he did 6 plus 6 plus 6 plus. So yes, he did that in his head. Because I said 6 times 6 is 6 sixes, and he was like, so he like was able to like figure it out. And then I said, and then put 2 zeros on the end, and he got it. He was like, I don't understand why they think this is so difficult.
That's fine.
Anyways, it was just, you know, comic. I know y'all know what it is, but some classes don't. I'm like, how many seconds are in an hour? They're like, and I'm like, okay, we need to go over this. Huh?
120.
So close.
Almost. All right, so h is going to be equal to 1 over 3,600 hours. So now I can use the trapezoidal rule with this information. So T is equal to 1 over 3600 over 2, which before I write everything out, I'm going to go ahead and rewrite that this is going to be 1 over 7200, just so I don't have to write the whole long thing out a second time. Times, and then the process is going to work the same way as it did with the other one where they gave us the table. So 0 plus 2 times 3 plus 2 times 7 plus 2 times 12 plus 2 times 17 plus 2 times 25 plus 2 times 33. I'm running out of space. Plus 2 times 41 plus 48. Okay, it's smushed in there, but we got it under control. So that's 6 plus 14 plus 24 plus 34 plus 50 plus 66 plus 82 plus 48, I think. I don't know if this is going to work out to a nice, like, even number or not, but if it's a decimal, you can go out to, like, 3 places or something.
It's a pretty even number.
I got an even Steven number.
Did you know?
What'd we get?
324.
Is that the divided by 7,200?
Wait, no,
Oh, okay. Well, that's why I was like, is it going to really be an even number? I was like, that's nice, I guess.
Yeah, that's what I got.
What?
0.045.
And is that it, or was there more to it? Did you
That was
round
it.
it? Okay. So relatively even. And if it had gone out like one more decimal place, I would just go ahead and write out. If it's like, you know, short enough where you can see the whole thing on your calculator, but if it looks like it keeps going, just round to like 3 or 4. Now, what units would be on this? Just think about trapezoidal rules finding what? Not for this problem in general, like area, okay? So what might my units need to be on this based on what I have up here?
Seconds squared.
Area is not time.
Distance squared.
Miles,
Miles.
okay? So this is miles, so that's how many miles it was. Now, it says, so this is the distance that it traveled in 8 seconds, okay? They say to give the final answer in feet, okay? So, how do I do that?
There's 5,280 feet per mile.
That is correct.
So we need to do that conversion and then tell me how many feet it is. Huh?
Gotta be so complicated.
This was like instructions in parentheses too. It wasn't like it, you know.
237.6
Feet.
But that's how those word problems work. They give you a table and then you answer the questions. So they're not, I mean, when I say word problem, like, it only is in the nature that it gives you something to read about it first before you do the math. All right, so let's do 2 Simpsons rule problems. So just as a refresher here, let's look back at, assuming that part didn't delete. So H we find the same way, okay, that we did before. This time it's H over 3. And keep in mind that the partition has to be an even number of subintervals for this one to work, okay? So then we do the first term, and then it's 4 times the next one, 2 times the next one, 4 times the next one, so on and so forth until you get to the end.
So it alternates between 4 and 2, like multiple.
Yep, and it just, whenever you get to your last term, like the last term just doesn't have anything on it. It's just by itself. So it won't have like, you don't have to stop on 4, if that makes sense. Like you can stop on the, like 2. You can see like this one went 2, then 4, then,
Oh.
although it probably, I'm guessing because it's even that it probably is going to work out this way, but until we do a couple, I'm not going to say that for 100% certainty, but I'm guessing with the even that that's what's going to happen. But anyways. All right, so use Simpson's rule with n is equal to 4 to approximate the value of the integral, and then it says to find the exact value, which I think, so problem 14 matches up with problem 2. Okay, so like we're going to do 14, and we did 2, although mine is since partially disappeared, I think. But,
So you're saying.
so basically we don't need to do part B, because when I give you problems, I'm going to give you ones that match. But part B would be done the same way that we did part B, or part C down here. So like the exact value's already there. If that makes sense. Because, like, you've already found it in the previous section. You don't need to go through and do it again. It's on the same interval and all of that. So, usually when I assign problems to this section, I'll be like, okay, do, like, 2 and 14 because they go together. And I'll, like, you can do them back to back if you want, if you don't care about your problems being out of order. So, that way you can just compare everything at the same time. All right, so 14. The integral from 0 to 2 of x squared dx. So what is h going to be?
I'm using n equals 4, right?
Yeah.
Okay. It should be 1/2.
Yep, so 1/2. So I'm going to do my table. We got 0, 1/2, 1, 3/2, 2. So at 0, it's 0. At 1/2, it's 1/4. At 1, it's 1. At 3/2, it's 9/4. And at 2, it's 4. So up to this part, everything's the same. Okay. Now we're going to use Simpson's rule. So S is equal to h over 3, so 1/2 over 3 times 0 plus, now the first one is 4 times, right? Go back and look, okay. So 4 times 1/4 plus 2 times 1 plus 4 times 9 over 4 plus 4. So this one happens to work out nicely because in here these 4's cancel. So I've got 1/6 times 1 plus 2 plus 9 plus 4. And what do we get? 2.67. Now, what did we get for trapezoidal rule on number 2? What did we get for part A? Okay, so we got 2.75 when we did trapezoidal. We got 2.67 when we did Simpsons. What did you get for the exact value? So part C on number 2.
2.6 repeating.
So, what do you think might be the case then? Which one do you think is the better one to use?
Simpsons rule.
Simpsons most of the time is going to be better.
So why don't they just teach
Because this one can only be used for n being even.
Oh wait, that's true.
And math is really done.
Yeah, I mean, it's a good question. And a lot of times you can pick whichever one. Like, more than likely, if you had something like this on the AP exam as a short answer type question where they're telling you to find the area or something like that, they're going to specify which one you need to use. But also, if they don't, it might be wise to do both and show, that. But I think these are more inclined to be a short answer type or a multiple choice type question where they're giving you options of it set up and you're supposed to pick which one is, right.
So what has to be even in the Simpsons rule?
N has to be even.
Okay, and it's 4.
Yeah. So when we did trapezoidal, it was even in every case, but it can be odd potentially in that. But odd is, it's kind of odd to have odd, like that. You don't see that a lot, but that's why Simpsons rule only works for even. So, let's see. 18 is gonna be the same as 6, so let's look at that one. And that's the other thing where I'm saying, like, if you want to do them back to back, so that way you don't have to, like, do the tables and stuff multiple times. So we've got the integral from 0 to pi, sine of x dx. We had found that h was pi over 4 when we did that before. Our table. 0, pi over 4, pi over 2, 3 pi over 4, and pi. And we had already found these values. 0, root 2 over 2, 1, root 2 over 2, and 0. So someone tell me how to set up Simpson's rule. Or what I would need to write.
So we got S equals h over 3, so pi over 4 over 3.
Okay.
Times 0 plus 4 times, 4 times the square root of 2 over 2 plus 2 times 1 plus 4 times the square root of 2 over 2 plus 0.
Yep. So I've got pi over 12 times, let's see, the 4 and the 2 here, reduce. So I've got 2 root 2 plus 2 plus 2 root 2. And we could reduce all this down by hand, but you can just type it in your calculator and get an answer.
How many decimal places do you go to?
Let's go to 3. I don't remember what we had when we actually did that problem, but
Okay. I got 2.005.
okay. And what did we get? Because I don't have it in my thing anymore. What did we get when we did part A of number 6?
Wait, no, RA is 1.89.
1.89. What did we get when we did it exactly? 2. So, again, this is much more accurate to what it should be, right? So, for problems, do I not have them written down?
So we're quiz on a section.
Yeah. Well, I think I might combine it with like 7.1 and 7.2, but we probably won't just test on this. Like, we probably won't test this with chapter 7. We'll probably just call it a day after the quiz on this stuff because I think it's relatively easy. overall. I mean, if y'all want to just quiz on this section, we can, but if you want it to be with other stuff, I mean, this would be a really short, not worth a lot of points quiz, so.
We can just put it with other stuff.
We could do it with like 7-1 and 7-2 or something like that.
Yeah.
Also, just, I mean, we have 2 weeks prior to spring break. I would like to be through chapter 7 by then, but I don't know if we will be, but we'll test wherever we're at before spring break, so we don't have to worry about that,
Yeah.
so. Or at least have at a minimum a quiz, but I think we should be ready for a test by then.
Yeah.
Okay, problems. Let's do. All right, 3 and 15 go together. 5 and 17 go together, so that's why I'm writing them like this. And then do 7 and 11. And those two are, so 7 will be like 8 and 11 will be like 12. So it'll be a couple little like word problem-y things. But
What's chapter 7 on?